Okay, in this demonstration we're going to look at how to use a chi-squared test of independence to check whether two categorical variables are related or not. Does the distribution of one categorical variable vary as another one is changed, or is it the same? Okay, so here we see that the eels data is already loaded, and we've got the two categorical variables of interest here: location, the location of each sighting, and species, the species of each eel that was sighted. Okay, again, there are other variables there like the ID of the eel and the length of that eel, and we're just going to ignore those figures for the time being. Okay, so to do a chi-squared test on this data, this is the raw data, we go to statistics and we find the menu item here, contingency tables. Okay, this is called a contingency table. We click on two-way table. We need to decide where we want the rows and column variables to be. It doesn't really matter, it's just how the table is going to be laid out. So we'll use location for the row variable and species for the column variable. Okay, under statistics here you can see you can choose to compute certain percentages or not, and you can work out which test to do. The default there is the chi-squared test of independence, which is exactly what we want. Okay, so we go back to the data, we'll just click OK. Alright, now what we see here is first of all a table of the counts for each of those combinations. So in the border area, Moringa, we saw 264. Okay, in sand, for example, Moringa, we saw 99. Okay, and this table is exactly the same as in lectures. Okay, and then down the bottom we see the chi-squared test itself. Okay, and we get the value 6.2621 for the chi-squared statistic on 2 degrees of freedom, and the p-value is 0.04367. Okay, so just significant at the 5% level. Right, if we were to use a 5% test. Okay, that's how we do it from raw data. Now sometimes we only have the summary data, so can we do that test then? Yes, we can. Again, we go to statistics, contingency tables, and you see here the bottom entry is enter and analyze a two-way table. Okay, we click on that, we see that initially we're set up with a 2x2 table to enter the counts. We want to increase the number of rows to 3, so we'll just change that slider and make the number of rows 3. I can actually edit the column headings here if I want. So we'll just change that one and that one, G.Vicinus. And we can change the row headings as well, so we'll make that border, grass and sand. There's not much room for them in this particular table here, but when they're printed below they'll make sense. Now we just fill in the numbers from the summarized data. Border Moringa was 264, border grass was 127, border sand was 99, Vicinus was 161 in the border, grass was 116, and sand was 67. Okay, and now we just click on OK, and again we get the chi-squared table down the bottom. We see we get the table printed again at the top, we get the chi-squared table at the bottom, same chi-squared statistic, 6.2621, 2 degrees of freedom, and a p-value of 0.04. So we reject the null hypothesis that the distribution across locations is the same. Okay, or alternatively we can say that we're rejecting the null hypothesis that the distribution across species for each location is the same. Turns out to be the same thing. The other way to say that is that we are rejecting the null hypothesis that the species and location variables are independent of each other. Okay, that's the end of this demonstration.